Chapter 4, Section 5. In this section, we are going to learn how to do some more division of polynomials through long division and synthetic division. The first thing they're going to do, though, is we're going to learn how to divide a polynomial by a monomial. So basically what we're going to do is this. We've already learned how to factor and then reduce, which is what we did earlier. I think it was in chapter 3. But now what I want to introduce to you is this. If you have a monomial in the denominator and you have a binomial or anything above in the numerator, then you can reduce all of these terms by the same number without having to factor. So for example, negative 36, 54, and 6 will all reduce by 6. So I know that the 6 will go into itself one time, 6 will go into negative 36 negative 6 times, and 6 will go into 54 9 times. Well, in the same sense, all of these x's will reduce by 1x. So this x will cancel out this one and this one. So on top, I have a negative 6x plus 9, and then on bottom it just goes to 1. So this answer is fine with me. If you went back and did what we did in chapter 3, which would be to factor out the greatest common factor, that would give you a slightly different answer because this is not completely factored. So again, this is not completely factored. It will factor again. It will. You can factor out a negative 3 if you want to, and that would be 2x. If we work this problem the way we did in chapter 3, we would factor out the greatest common factor out of the top, which would be a negative 18x. And if you did that, you would come up with a 2x minus 3, and then on the bottom you still have that 6x, and then from here we would reduce the x's, and then the 6 will go into 18 negative 3 times. So what you have is negative 3 times the 2x minus 3. And so that's where the answer comes from. But again, on the test, when you work these problems, the main thing I need you to understand so that when we go into chapter 5, you'll already have this under your belt is if you have a monomial on the bottom and anything else on top, the only way that you can reduce is if all 3 or 4 or however many terms will reduce by the exact same greatest common factor or common factor. So this answer for now will be fine, but if you go back and do what we did in chapter 3, you should come up with the factored form. But like I said, for this chapter, for this section, this answer would be fine. So let's go here. Like I said, the main concept that I want you to understand is if you're dividing by a monomial, and on top you see addition and subtraction, which means you have a binomial, trinomial, whatever. In order to reduce, you have to reduce every term by the exact same number. So for example, I would reduce the 40, the 72, and the 8 by 8. So 8 will go into itself one time, 8 will go into 45 times, and 8 will go into 72 9 times. I can also reduce by an x squared, so that x squared will go out to 1. This will turn into x squared, and this one will turn into x to the third. And then I can also reduce everything by at least 1y, or at most 1y. So we'll have y to the 4th and y to the 6th. So what we have here is 5x squared y to the 4th plus 9x to the 3rd y to the 6th, and it's over 1, and that would be my goal. So this answer is good for me. So anytime you're going to divide by a monomial, this is the process that you're going to take. Just make sure you reduce every term in the whole entire problem by the exact same thing. So what happens if you have division by anything aside from a monomial? So for example, what if you're dividing by a binomial? Well, what we're going to do is we're going to go back to third grade division. I'm going to do long division using polynomials. You're going to do the same thing. You're going to set up a basic long division problem with the divisor on the outside and the dividend on the inside. And make sure you arrange both of these in descending order according to their exponents. Then what you're going to do is you're going to find the first term of the quotient by dividing the first term of the dividend by the first term of your divisor. So this is the division part. And then you're going to multiply the entire divisor by the term of the quotient found in step 2 and position the product to be subtracted from the dividend. Now when you position the product, make sure you line up your like terms. And then you're going to subtract, cross line, change the sign if you need to, and then you're going to bring down the next term, and then you're just going to start all over. So let's see how this goes. Remember, divide, multiply, subtract, bring down, daddy, mother, sister, brother. So we're going to set up this x minus 2 is called your divisor, so that's going to go on the outside. And then this 4x to the third minus x squared minus 2x plus 6, that's your dividend, and that's going to go on the inside. Alright, one thing about this is when you set up your dividend underneath the bar here, make sure you do not skip exponents. So notice our exponents goes from 3, 2, 1, 0. But over here, notice we go from 4 all the way to 0. Well, you're going to have to put zeros in those placeholders, and I'll show you how to do that in just a minute. Okay, so step number 1, once you get your setup, step number 1 says to take the first term of your dividend and divide it by the first term of your quotient. So you're going to do 4x to the third divided by x. Well, you know, if we do 4x to the third divided by x, this is going to cancel out to 4x squared. So that's what goes on top. So 4x to the third divided by x is 4x squared. And then you're going to multiply that around. So you're going to take this 4x squared and you're going to multiply it times this whole entire binomial. So 4x squared times x is going to be 4x to the third. 4x squared times negative 2 is going to be negative 8x squared. And then you're going to subtract. And remember, this subtraction sign goes to this whole entire binomial here. So 4x to the third minus 4x to the third, that just cancels out. And then you have negative 1x squared minus a negative 8x squared. Remember, double negatives go to plus, so you have negative 1x squared plus 8x squared, which is going to give us a positive 7x squared. So you did your subtraction, and then we're going to bring down the negative 2x and start all over. So our first step is to divide, and when we divide first term by first term. So 7x squared divided by x is going to be 7x, a positive 7x, and that's going to go up top. Then we're going to do our multiplication. So we're going to multiply this 7x times this binomial. So 7x times x is 7x squared. And 7x times negative 2 is negative 14x. And then we're going to subtract. 7x squared minus 7x squared, that goes to 0. Negative 2x minus a negative 14x is going to be a positive 12x. And then you're going to bring down that plus 6. Alright, last time, and I know it's the last time because I've run out of numbers here. So we're going to do 12x divided by x, which is going to give me 12, positive 12, and that's going to go up top. So 12 times x is going to be 12x, and 12 times negative 2 is going to be negative 24. And then if we subtract, 12x minus 12x goes away, and 6 minus a negative 24 goes to 6 plus 24, which is going to be a 30. So your answer is going to be 4x squared plus 7x plus 12. And then technically you would write it as your remainder over your original divisor. But for our purposes, and like I said, this is how you're going to see it in the back of the book. But on the test, I am going to ask you what the quotient is, and you're going to tell me it's 4x squared plus 7x plus 12. And I'm also going to ask you what the remainder is, and you're going to tell me 30. So let's try one more time over here. So the x plus 2 is going to go on the outside. And then that x to the fourth minus 16 is going to go in the inside. But you cannot miss exponents. So we've got to put in here every single exponent placeholder with a 0. Okay? So now we have 4, 3, 2, 1, 0. So we're not missing any exponents, and you've got to do that. The reason you've got to do that is because you're going to be lining up like terms, and if you don't do this, you won't have like terms. So start with your division. Divide x to the fourth by x, and you're going to get x to the third. And then you're going to multiply this x to the third times this whole entire binomial. So x to the third times x is going to be x to the fourth. X to the third times 2 is going to be 2x to the third. And x to the third times 2. And then we're going to subtract. So the x to the fourth minus x to the fourth will go away. 0 minus 2x to the third is going to be a negative 2x to the third. And then we're going to bring down. Alright, so we'll start all over. Divide first. So we're going to divide the first term, negative 2x to the third, by the first term here, x. And when you do that, you're going to get negative 2x squared. We're just dividing an x out. So multiply around. So we'll take negative 2x squared times x, which is going to be negative 2x to the third. And negative 2x squared times 4 is going to be negative 4x squared. Subtract. These two are going to cancel out, and you get 0 minus a negative 4x squared, which is going to be a positive 4x squared. And we're going to bring down that plus 0x. Okay, so keep going. Divide 4x squared by x, and we're going to get 4x, and that's going to go up top. And then you're going to multiply around. 4x times x is going to be 4x squared. And 4x times 2 is going to be 8x. And then we're going to subtract. 4x squared minus 4x squared goes away. 0 minus 8x is negative 8x. And we'll bring down that negative 16. Last time. Negative 8x divided by x is going to be negative 8. Multiply around. Negative 8 times x is negative 8x, and negative 8 times 2 is going to be negative 16, and this time when we subtract we get 0. So my quotient, my answer, is going to be x to the third minus 2x squared plus 4x minus 8 with a remainder of 0. Alright, so let's set this problem up. You're going to have 3x plus 1 on the outside, and 3x to the third minus 5x squared minus 23x minus 7 on bottom, or inside. So if we divide, 3x to the third divided by 3x is going to give me x squared. Multiply around, x squared times 3x is going to be 3x to the third, and x squared times 1 is going to be plus 1x squared. And if we subtract, 3x to the third minus 3x to the third is 0. Negative 5x squared minus 1x squared is going to be a negative 6x squared. And bring down the negative 23x. 3x will go into negative 6x squared, a negative 2x times. So negative 2x times 3x is going to be negative 6x squared. And negative 2x times 1 is going to be negative 2x. Subtract. These two cancel out. Negative 23x minus a negative 2x is going to be negative 21x. And we're going to bring down the negative 7. So divide one last time. Negative 21x divided by 3x is going to give you a negative 7. 7 times 3x is, or negative 7 times 3x is negative 21x, and negative 7 times 1 is negative 7. So you get a remainder of 0. So the quotient is going to be x squared minus 2x minus 7, and your remainder is 0. Alright, so this one, notice we have a trinomial as our divisor. So this problem looks pretty intimidating, but it's actually not that bad. So our setup is still the same. Our divisor is the trinomial of 5x squared minus 2x minus 1. And the dividend, again, make sure you don't skip exponents. So we have 5x to the third plus 8x squared minus 5x minus 2. Alright, so if we divide, again, process is the same. First in the dividend divided by the first of the divisor. So 5x to the third divided by 5x is just simply x. Multiply around. It's got 3 times this time. X times 5x squared is 5x to the third. X times negative 2x is negative 2x squared. And x times negative 1 is negative x. And then if we subtract 5x to the third minus 5x to the third, that goes to 0. 8x squared minus a negative 2x squared is going to be 10x squared. Negative 5x minus a negative 1x is going to be negative 4x. And bring down that negative 2. Go one more time. So 10x squared divided by 5x squared is going to be a plus 2. Multiply around. So we have 2x times 5x squared is going to be 10x squared. 2 times negative 2x is negative 4x. And 2 times negative 1 is negative 2. And when we subtract, all this goes to 0. So you have a quotient of x plus 2 and a remainder of 0. Alright, so that's long division. We learned how to do that in 098 and in basic algebra. So now what I'm going to do is I'm going to show you another technique called synthetic division. And notice synthetic division is the easiest of the divisions, but you can only use synthetic division if your leading coefficient of your divisor, the thing you're dividing by, is 1. So how are we going to do this problem? Well, in synthetic division, you don't use any variables. You just use the coefficients. And so you're going to write the coefficients of the dividend, and then for the divisor, you're going to use the opposite, and this is very important, opposite of the constant, so that we can add rather than subtract. Then we're going to bring down the first coefficient of the dividend, and you're going to start to multiply. You're going to multiply the first coefficient of the dividend by the divisor. Add the product to the next term in the dividend. Then you're going to continue this process until all terms in the dividend are used. The last row is the quotient. The bottom row is your quotient. If a number that is not 0 is at the end, this is your remainder. It is to be written over the original divisor, or the way that I asked you to write it earlier. So let's look at this. For synthetic division, step number 1 says to write the coefficients of the dividend. So the coefficient of the dividend, this is my dividend, this is my divisor. The coefficients of the dividend, and remember you cannot skip exponents, are going to be 4, negative 1, negative 2, and 6. Okay, step number 2. Step number 2, for the divisor, use the opposite of the constant so that we can add rather than subtract. So here's my constant, and I see a negative 2. Well, the opposite's going to be positive 2, and that's going to go on the outside. Alright, so that tells me that I can add. Step number 3, bring down the first coefficient of the dividend. So we're going to take this 4, and we're going to go straight down with it. Step number 4, multiply the first coefficient of the dividend by the divisor and add the product to the next term in the dividend. So a lot of terminology going on there. So basically what we're going to do is we're going to multiply 2 times this 4, and we're going to put it under the negative 1. So 2 times 4 is 8, and put it under the negative 1. And then we're going to do what this sign tells us to do. We're going to add. Negative 1 and 8 is going to be 7. 2 times 7 is going to be 14. Put it underneath the negative 2. Negative 2 and 4 is going to be 12, and 2 times 12 is going to be 24. Add those together, and you're going to get 30. So your quotient is going to be right here. These numbers are your coefficients of your quotient. So notice we have an x to the third up here, but we're dividing an x out. So now we're going to have a 4x squared plus 7x plus 12, and the remainder is 30. Let's try again over here. We're going to write the coefficients of our dividend, not skipping any exponents. So we have 5, 6, and negative 8. And on the outside, we're going to take the opposite of the constant of our divisor. We're going to add, so drop the 5 straight down. Negative 2 times 5 is going to be negative 10. Add them together and you're going to get a negative 4. Negative 2 times negative 4 is going to be a positive 8. Add them together and you're going to get a 0. So this time your quotient is going to be 5x minus 4 with a remainder of 0. Alright, so for this problem here, we're going to have 1, 0, 0, 0, negative 16, and negative 2. So we're going to drop that 1 straight down. Negative 2 times 1 is negative 2. Add them together and get negative 2. Negative 2 times negative 2 is going to be a positive 4. Add them together and get 4. Negative 2 times 4 is going to be a negative 8. Add them together and you'll get negative 8. And negative 2 times negative 8 is going to be a positive 16, and your remainder is going to be 0. So we're going to have x to the third, this is my quotient, x to the third minus 2x squared plus 4x minus 8 with a remainder of 0. Alright, last one. On the inside, we're going to have 1, 4, and we're missing the x squared term, so that's going to be 0, negative 7, negative 1, and we're going to take the opposite of negative 3, which is going to give us a positive 3. So we're going to take this 1 and drop it straight down. 3 times 1 is going to be 3. Add them together and we're going to get 7. 3 times 7 is going to be 21. Add them together and you're going to get 21. 3 times 21 is going to be 63. Add those together and you're going to get a 56. And 3 times 56 is going to be 168. And add them together and you're going to get 167. So we're going to have as our quotient x to the third plus 7x squared plus 21x plus 56, and as our remainder, a 167. So what I would like you to do is I would like for you to complete these numbers on page 216 and bring any questions that you may have into class.